Hello! I recently got a pretty strange YouTube comment. Strange is not the right word, but mean YouTube comment. We'll put it there. And I got the great idea to half-ass some computer vision and make an absolute shitpost of video where I have every clip of me, well, not every clip as I'm about to show you, many clips of me drinking water from my sippy cup throughout 2025. And I want to walk you through how I made it because I think there's some instructive parts to it. Also some places where I cut a bunch of corners and it still turned out all right. So let's do that. So I believe I actually uploaded the code for this. Oh, I clicked on a video. No, I clicked on something that didn't do anything. Anyway, I believe I put this on GitHub. So if you want to find it, it's Anthony writes code/slurp. I've no documentation, nothing whatsoever. So I'm gonna walk you through how I did it and then go into that. So I actually took some frames from some videos so I can walk you through this. But the basics of this script is it takes a bunch of video file names and it processes them with CV2. I didn't realize that you could just pass the file name to video capture and you just work with it as usual. I'm used to working with webcams for my Pokemon automation stuff, and actually a lot of the stuff that I learned from Pokemon automation was really useful for this. But anyway, it's basically capture the video, go through each of its frames. I actually skip a bunch of frames here because it makes it slightly faster, and I don't actually care to look at every single frame in the video. So I dropped it from 30 FPS to what, I guess this is 6 FPS? No, 5 FPS, because ignore 5 frames and get the 6th one. Anyway, I dropped down the FPS so that I don't have to process this as much. And, ignore that. That was me giving you things so that we can actually show this video here. And then basically recording the start and stop time where I think it looks like there's water in frame. I took a couple of frames just so I can show you what that'll look like. So for instance, this is a frame where it's behind my head so you can't see it. This is a frame where water is not in frame. I'm just sitting there giggling at something, who knows. And then here's one where the water bottle appears. And this is kind of the heuristic that I used for am I drinking, is does this water bottle appear here? And I'm pretty lucky here in that the water bottle is a fairly unique color. I say fairly unique, however, you'll notice like the blanket behind me is fairly close in color. My little car model is fairly close in color, and my art up here is also fairly close in color. Also carpet is fairly close in color. And when I wear a dark blue shirt, I mean, I'm not wearing a dark blue shirt right now, but when I do, it blends in. And that's actually a problem that I didn't bother solving. I just wanted something quick and dirty that I could quickly throw together a bunch of clips and get some functional shitpost happening. So that's what I did. I didn't bother to make this perfect. And so what I first did was try to figure out the colors that represent this bottle. And I have a script for my Pokemon automation. This tab, sure. For my Pokemon automation that allows me to grab an image. So for instance, let's take frame 300, which has the water bottle in frame. It allows me to grab an image, zoom in on a particular part, and let's say I want to figure out the rough HSVs of this light blue color. I might click around on a bunch. It records every pixel that I click on, and then will help me get ranges out at the end. So I get a few of these light colored pixels, and then I press Q. It'll give me a range of HSVs, and then I can use that to select whether pixels match those. HSV being hue, saturation, and variance. It's basically a color scale that, let's see, HSV graph. Yeah, it's basically a color scale that looks like this and allows you to, track a very specific color rather than RGB, which is not as linearized. if you can call it that. Like all of the blues will have this particular H value, and so it's really just varying the other two parts to figure out what other color it is. Anyway, HSV tends to be a little bit easier for me to, or I guess easier in general to select particular pixels. So I did that a bunch. I figured out a bunch of the colors that represent this this water bottle. And honestly, this water bottle is not the easiest as well, because it's made up of greens, blues, and purples, which covers quite a lot of variety in colors and quite a lot of colors that I might wear as well, which is the other problem. So from that, and yeah, we're getting another slurp in this video too. From that, I was able to get a bunch of threshold ranges. I thought about doing an object detection training, and that just didn't sound fun. I would have had to, you know, train a machine learning model for forever, and I don't have time for that. HSV range is good enough, and so I went with that. So what I ended up doing is cropping out a corner of my camera that's about here-ish, so below here and to the right over here. Because, you know, I'm not gonna be waggling my water bottle up over here or over here, hopefully, and so it helped me just specifically know when it was in frame. This also helped reduce the false positives from the background. I wasn't able to eliminate the false positives from my chair. My chair is actually detected as a water bottle, but let me walk you through an example frame and what I did here. So these are the ranges. I basically just check all of these ranges and combine them all together, and that gives me a, you know, white versus black pixels, white being ones that I detect, black being ones that I don't. I then smooth it. I originally was going to try and find clusters of pixels of a particular size, but that turned out to be way more work than I wanted to do, and so I just said, if I see more than 1800 matching pixels, it's probably a water bottle. Let's run I have a debug script that allows me to do one frame at a time, so let's run it on, I guess let's run it on the water bottle frame first. This is gonna spit out, oh, I have them from before. This is gonna spit out my thresholded images. So this is the crop that I'm looking at in that particular frame. So it's, again, just the bottom left corner. This is after selecting the pixels that look water bottle colored. You'll notice that I didn't do a very good job of, especially the lighter colors, getting ranges that match well here. So I could have improved this further by matching more ranges, but you'll also notice like even stuff in my background is showing up here. Like it's not perfect, and it didn't need to be perfect. And then after the smoothing, you'll notice that the pieces become a little bit more interconnected. This is a process, I believe it's called erosion and dilation, where it uses basically a stamp and makes sure that it results in it smoothing edges. And then I just count the pixels, and that was good enough. From that, I had a series of ranges. So for instance, this out file here, where I have start and end times. And most of these are fairly accurate. Some of them are a little short. Some of them are literally just when the water bottle's in frame. But I might want like a few seconds before or a few seconds after. Sometimes they're like right next to each other. So you can see here, it detected it from 3851 to 52, then it didn't detect a frame, and then it got it from 52 to 52. That's not great either. Also, a 0-second clip is not very helpful. So I had to do a little bit more post-processing on this first set of duration output. And basically, I just implemented the interview question that I used to ask at Yelp, what I would call combined business hours, but in this case it's durations and frame durations. So I basically just add a few seconds before and after. Figured widening it by 6 is not that big a deal. And after all, at the end of the day, I was going to sift through each of these clips and manually put them in my video editor and trim out the ends anyway. So if I had a few extra seconds here, it wasn't the end of the world. And this allowed me to combine a lot of ranges. The other thing that I did is I skipped any ranges that were really long. This helped me in particular cases where like I was wearing a dark shirt and so the entire video was me drinking. Also things like my fidget toy, suspiciously the same color as my water bottle. So there are a lot of times where I'm like showing off my fidget toy and it's like, no, it's not the water bottle. This one too, also it figured out. So I was pretty surprised to see like how accurate it was, but also like what things could trick it. Okay, but once I did this, I was able to run every single one of these through FFmpeg. So basically take those durations and pass them into start and end, or SS and TO in FFmpeg, and output a whole bunch of clips. Yeah. 1,077 clips generated from this. And from there, I just went through them one at a time and dragged them into my video editor. So here's all of those clips that I sifted through and then edited them together, and you get the resulting shitpost video. But anyway, I thought this was interesting. Kind of an example of like good enough was good enough. And, you know, I think the result is kind of funny. So maybe you'll think it's funny too. Or maybe I just have a broken sense of humor. Anyway, that's all I have for today. Thank you for watching. I will see you in the next one.